Okay, so I will be demonstrating whiteboard problem advanced number 2. So the first question, part A, is asking us to determine the total impulse given by the ball. So we have a graph that is a trapezoid. And in order to find the total impulse, it's the area underneath the graph. So what we need to find is the area of this triangle right here, and this rectangle, and add them together. So the area of a triangle is half times base times height. So we have half, and the base of the first triangle is 4, and the height is 2, and that gives us 4. The second triangle is exactly identical, so that gives us 4 again. And the area of the rectangle is length times width, and that is 2 times 2, so that gives us 4. And when we add it up, we know that our total impulse is 12 newtons seconds. Okay, for part B, we need to determine the horizontal velocity of the ball immediately after the collision. So we know we have the equation of the impulse momentum theorem. And we just figured out that our force was 12 newtons. And we know that our mass is 5 kilograms, and we're solving for delta V. So once you solve over, turns out to be 2.4 meters per second. Alright, moving on to C, the first part of C. We need to determine the following for the cube immediately after the collision, so we will need to figure out the speed. So when you rearrange the equation, you can get this. So now what we have to do is we want to be solving for the final velocity of the cube. So now we just have to plug in our numbers, and we know that the mass of the cube initially was 0.5. And we know that its initial speed was 26. We know that the final mass of the cube was 0.5. We're solving for VF. And we know that mass of B was 5. And the final velocity of B was 2.4. So we bring that down. We multiply these two together. We get 13. We still have 0.5 velocity of F. And 5 times 2.4 gives us 12. And when we subtract the 12 over, we get 1, and we divide by 1 by 0.5, and we get V of F to equals 2 meters per second. Now, the second part of C wants us to determine its direction of travel, if it is moving, and we can tell by the graph and also by the picture it's moving to the right, which is the positive direction. The next thing we need to find is part D, which is to determine the kinetic energy dissipated in the collision. So we know that the kinetic energy formula is 1/2 mv squared. And we also know that it is kinetic energy, the initial kinetic energy, minus the final kinetic energy. So when we put it in cubes and ball terms, we get 1/2 mv, well actually 1/2 the mass of the cube, times the velocity. Alright, let me just erase this. Okay, so we get 1/2 the mass of the cube and the velocity of the cube, which is the final velocity, plus 1/2 times the mass of the ball times the final velocity of the ball. And then we want to subtract the kinetic energy of the initially of the cube, which is okay. So now we just want to plug in our numbers, and we have 1/2 times the mass of the cube times the final velocity of the cube plus 1/2 the mass of the block times the final velocity of the block plus 1/2 times the mass of the cube, also times the initial velocity of the cube. And when this all works out, we get delta K to be 154 joules. Okay, the next thing we need to solve for is the distance between the 2 points of impact of the objects with the floor. So we know our equation for a projectile, delta y equals 1/2 at squared plus voyt. And we know that this is 0 with delta y. So when we plug in our equation, we know that delta y is given as 1.2 meters. We know that the acceleration is negative 9.8, and we're solving for t. So when t gets solved out, t squared equals 0.2448, and square root, we get t to be 0.49 seconds. Okay, so now we need to use time, which we just figured out, to solve for the x distance of the block. So, for the block, we can use the delta x equation, where we know that the acceleration in the first part of the equation is 0. So that leaves us with delta x equals vox times t. So we know that x equals vox t. So when we're solving for that, we know that the velocity of the x was 2, and we just solved for time, which is 0.49. And when we solve for that, we get x equals 0.98 meters. And now we want to solve for the ball's x distance. So once again, we know that the first part of the equation is 0, so it's x equals vox times t. And we know that the velocity was 2.4, which we solved for earlier, and the time is 0.49. And we can solve that x equals 1.176 meters. Now we can take our ball's distance, which is 1.176 meters, and subtract it by 0.98. And when we subtract those two, we get 0.196 0.196 meters, which can be rounded to 0.2 meters. So this is an explanation of whiteboard problem advanced number 2.